Thank you. So if we are at the point -2, -6, it means that we're taking the x value and we're not taking the x value, sorry. We're taking the output, the y value, and we're compressing it, or we're going to multiply it by a half. What is 1/2 of -6?
-3.
-3. So let's look at our next green point right here. What is 1/2 of -3?
1.5.
A -1.5. That's not right. Skip that one, because I did that backwards. Skip it, we'll go back to it. Okay, the graph of g of x equals x minus h, the quantity squared. We should have just plugged in two numbers and fixed that, and I'll go back and do that. H minus x, the quantity squared, is the graph of f of x translated horizontally. So we're going to take the parent function, and we're going to move it to the right or to the
Left.
So when the number is inside the parenthesis, we're going to move it to the right or to the left. When the number is inside the parenthesis, that tells us to move it to the right or to the left. So let's look at number 5. Let's look at number 5. So if you guys remember from doing that activity in Desmos, or if I were to ask you, what are the roots of this function, what would you tell me? Mason. X equals -4. So I know that this graph is going to cross the y-axis at -4. Well, let's look at what happens. So here's my parent function, 0, 0, 1, 1, 2, 4, or -1, 1, -2, +4. And I'm taking the vertex and I'm moving it 4 units to the left. So what takes place inside the parenthesis, whatever your operation you're doing inside the parenthesis, you're going to move in the opposite direction. And by that, here's what I mean. What I mean by that is when you see a +4, you're actually going to move to the left. When you see a minus something, you're going to move to the right. So positive means move left. Negative means that you're going to move to the right. Okay? What do you think? Good, bad?
Good.
Okay. Decent? Let's look at number 6. So what do you think we're going to do with this function? Mason.
We can graph the parent function.
So 0, 0, 1, 1, 2, 4, -1, 1, -2, +4.
Then we can horizontally shift it 2 units to the right.
2 units to the right. So our new points are 2, 0, 1, 1, 3, 1, 4, 4, and 0, 4. Those are your new points. Perfect. You're really not doing any graphing today. You're just explaining equations, okay? You're not going to do any graphing today in your homework. You're just going to look at an equation and tell me what's happening. So what about this graph? What's going to go on with this one? Or this function? Colton. Up to and to the what? Yeah, so your parent function, 0, 0, 1, 1, 2, 4, -1, 1, -2, +4. You're going to take your parent function, or each point of your parent function, and move it up 2 units, and this means that we're going to go to the right 4. So 0, 0 is going to go up 2 units and to the right 1, 2, 3, 4. 1, 1 is going to go up 2 units and to the right 1, 2, 3, 4. 2, 4 is going to go up 2 units and to the right 1, 2, 3, 4. -1, 1 is going to go up 2 units and to the right 1, 2, 3, 4. And -2, 4 is going to go up 2 units and to the right 1, 2, 3, 4. And this becomes your new function. So up to right 4. What do you think? That was awesome. Good job on that. Okay, I knew that was going to happen. Number 8. Someone tell me what's going to happen with number 8. Cameron.
Well, when you graph parent function.
So 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. Here's my parent function.
You're going to move the vertex to the left 1 and down 5.
Left 1 and down 5. So left 1, I need to slide it up a little bit so you guys can see what's going on. Left 1, down 1, 2, 3, 4, 5. 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 Perfect. Absolutely perfect. What do you think? Okay. How many more examples do we have? 2. Okay, we're not going to do them. Here's what we're going to do. We're going to go to the homework, and I'll go back to this. So this is your homework for tonight, but we're going to do some examples from the homework. So I gave you 1 through 7 odd. We're going to do a couple of even problems, like 2 and 4, and then the 8 through 16 even, we're going to do 9 and 11. So the directions ask you to tell me what is going on in this graph. Explain this graph, and I'll read the directions exactly. So the directions for number 2 say, listen, describe how the graph of each function is related to the parent function, or the graph f of x equals x squared. So how is this graph related to the parent function? Well, what do we know? The vertex is shifted how much? I heard someone say it. The vertex is shifted right 2 units. And what else can we say about it? Is it compressed or is it stretched? It's compressed vertically. It's compressed vertically. So you would write this function out, and this is what you would tell me. That's what you're doing in your homework tonight, okay? So this is not like you're doing odd problems, but I just wanted to kind of give you an example. What about number 3? Same direction, or number 4, same directions. What is different about this graph compared to the parent function? Jackson.
Is it shifted to the left 6?
We move it to the right and to the left when it's inside of a parenthesis. When there's no parenthesis and you just have a positive or number, it goes up. So the vertex is moved up 6 units. So do you guys see what you're doing with your homework? Okay. What about number 9? The directions for number 9, same thing. Describe how the graph is related to the parent function, f of x equals x squared. Missy, number 9.
The graph is reflected across the y, the x-axis.
Yeah, I'm going to rewrite it so you can see really what it looks like. Negative, let me try it again. Yes, Missy, you're right. I'm just going to put the x coordinate first. Equals negative x squared minus 7. So you said that the graph is reflected across the x-axis. You could write opens downward if you wanted to. That's the same thing. Opens downward. And you said that the vertex is moved what? Yeah, good job. 7 units. So again, all you're doing really is writing out the function and then describing how it's different than the parent. No graphing taking place. You just have to think about it. What about number 11? And it says h of x, it's hard to type this on a smartboard, equals 6 plus 2/3 x squared. Isaac.
So, wouldn't it be compressed vertically?
Yeah, good job. It's compressed vertically.
And it would be up 6.
What's going to be up 6?
What's it called? The vertex.
Vertex moved up 6 units. Perfect. What if I had h of x equals 4x squared? I just want you to use that word once. What's that going to be?
It's stretched.
Yeah. This is called stretched. This would be a vertical stretch. So this is being stretched vertically, and that's it. Okay? Sir?
I see what problem we're doing. I did.
Yeah, I just needed to do these examples, okay? So here's your homework for tonight. I'm stopping it.